Okay, guys, I'm going to go over this problem right now. All right, I'm going to tell you why. I'm going to tell you how to get the angle measurement between the two hands. And that's at 11:47. All right.
Okay.
So look, we have a clock, right?
Yeah.
We've got a clock here. Everyone knows what a clock looks like, right? The two hands. We went over this yesterday, right? So we have how many divisions in the clock? I went over how to calculate 9:15 yesterday, right?
Nope.
Yeah, do I need to go over that again?
No.
9:15? Okay, so here's 12 o'clock. 1, 2, 3, all the way around the circle. Right? So at 11:47, the hour hand is right over here. It's a little bit above the 11. And the big hand is 2 notches above the 9. You see that? Because every notch has 5 minutes. So the big hand is right here. So I'm going to color this using a different color pen, so you can see. The hands. Is everyone to the green lines? All right. So the basic idea is we want to find the angle measurement between these two hands. Okay. Now, let me ask you this: how many degrees? We said yesterday that there's 360 degrees in a circle, right? Everyone agrees that there's 360 degrees?
Yeah.
Okay. And I proved that, right? I proved that by saying that there's 4 right angles within the circle, so that's why there's 360, right? So if there's 12 hours in a day, 12 hours around the clock, how many degrees are there for each hour? That's simple, right? We have 360, divide that by 12, and then we get 30 degrees per hour. That's it. 6 degrees. Why? Because there's 5 little divisions here, so 30 divided by 5 is 6. Okay? So each one of those has 6 degrees. Does everyone see that? Okay? Now, everyone agreed with me that each hour has 30 degrees, right?
Yeah.
Look here. There is 1 complete hour between the two hands. Does everyone see that? There's 1 complete hour between the two hands. So what does that mean? What does that show? That means that there's at least 30 degrees there, so we're going to add 30 to whatever we think the final angle sum is going to be, okay? And we also know that this big hand, let's try to calculate this little sliver right here. I'm going to use a different color. Let's try to calculate the sliver that the big hand makes. Does everyone see that though? The little sliver here between the big hand and the 10. So at 47, does everyone agree that it has moved 2/5 of the way?
Yeah.
So how much is left after it's moved 2/5? There's 3/5 left, right? So what do? We do 3/5 times 30 degrees. Okay, because we already said that each hour has 30 degrees. So 3/5 times 30 degrees, and what do we get? This is 6, right? So 3 times 6 is 18. So we know that this part right here is 18 degrees. So far our total is 30 plus 18, right? Now the tricky part is finding out what is the angle measure between the small angle and the 11. All right, does everyone see that? Now, how do we figure that out? Now, we know a key piece of information, right? We know that the small hand moves in proportion to the big hand. Everything is proportional. Okay, everything is proportional. So for every minute that the big hand goes, the hour hand goes 1/60th of the way to the next hour. Does everyone see that? Look, if the length of one side of the square is 1, okay, and if I increase the length of a side by 20%, okay, so imagine the square getting increased a little bit. until it becomes a bigger square. I want to know the percent increase in the area. By what percentage does the area increase? Do you understand that? How much does the area increase by? So this is the extra area, right? I mean, the side is 1, right? And it increases by 20%. So that's the hint that I'm giving you. So this little part is going to be what? This is going to be 1.2, right? The total length of the side after the increase is going to be, the total length of the side after the increase is going to be 1.2. Does everyone see that?
Oh, you're giving us a hint.
Yes, okay. I want to know the difference in percentages in the areas. Okay, what is the area increase and what is the perimeter increase? If the increase of the side of the square is 33%, if the increase of the side of the square, I want the area increase and the perimeter increase. Alright? I want the area increase and the perimeter increase. Guys, look. Shh. Shh. Who wants me to do a review of multiplication though?
No. We can do it. I can prove it.
Yes or no? Guys, do you want me to do a review of multiplication? Guys, what's the original area? Let me ask this again. What's the original area? The original area is 1. Why? Because it's
1 times 1.
1 times 1, exactly. What's the original perimeter?
Original 4.
Exactly, it's 4. Guys, let me outline to you the steps that you need to take in order to, Sid, you can work on your bracket. Guys, let me outline the steps that you need to take to find the percentage increase. Guys, look, you square the side to find the new square, right? Do we have that? And then we subtract the original area, which is 1, to get some decimal, and then we convert that decimal into a percentage to find the percentage increase.
He seems to the high pitch.
One time in one of these, he just really the over.
Yeah, you have to get both.
That's bad.
No. He has special shoes.
That's bad.
No.
He goes to that song.
I want the area and the perimeter of the new square. Okay, the area and the perimeter. That's good. Sure. No, I want the area and the perimeter. You need that both. You need that both. What's the area and the perimeter of the new square, guys?
Which square is the new one?
The new square is the square that has a side increase of 33%.
I got the increase before they get.
No, guys, you need both. You need both parts.
I got one. I got half.
You got half?
Same here.
Okay, do the other half. The perimeter is easy too.
Wait.
You just multiply the side by 4.
I just did the area.
Wait. This first square.
4 times 1 is? Exactly. So you subtract those two numbers from what you get with the 33% increase of the side, and then you get the percent increase of the new shape, of the new square that you have. Okay? You do a subtraction to find the percent increase.
Yeah,
Do you understand? Guys, you do a subtraction to find the percent increase.
I'm not on that yet. Yeah.
Who's ready? Who has it?
Wait.
Percent. This is degrees.
Get it.
Okay, but that's good. Hold on, let me just write these down. That's good.